configuration and tuning. As I mentioned before, we recommend doing your configuration in the configuration plugin. So the static plugins for dotCMS, we bundle it with a configuration plugin that can also be used as a model for creating your own plugins if you need to. If we run into some sort of bug and provide a hotfix for it, that hotfix will go here in the plugins folder and just be unpacked into its own subfolder. So going into dotCMS config, we see a tree that looks like the dotCMS application tree. We've got a conf folder, we've got a JSP folder, there's a lib folder, and you can place JSPs, CSS files, XML files, whatever as needed in the place here that mirrors where they would go in the actual application tree. When you run the deploy plugins script, what it will do is it will copy all of those files to where they need to go. There is one particular place where there are special files. That is this root folder here. If we look in, for example, conf, these files have a -ext. That means it's an extension. The plugin deployer will go looking for dotCMS config cluster properties, and it will find whatever variables we set here in that original file, comment them out, and replace them with what's in this file. Objects in the root folder, we simply completely overwrite. And those are for things where you want to be absolutely sure that there is no confusion about which variable to use, which file to use. So things like your database connector, your Tomcat server XML. Those are things we want to make sure we're completely blowing away the original and replacing it with this new file. So one of the first things that we will do when we are setting up a new dotCMS environment is we will, and by default this root folder is empty, you'll need to create the folder structure underneath it as needed. So in this case, the first thing we have is our bin, because you're going to want to change your startup script. By default, dotCMS has 1 gig of memory configured, which is not going to be sufficient beyond a development environment. So the first thing you will want to do, in this case I've already changed it, you want to come in here and change your XMX, so the memory you're allocating to dotCMS. In my case I've set it to 2. Save that, and you now have a new startup script that's going to replace the original startup script. So then we look at our .server. We've already created a Tomcat folder here. Under Tomcat, I've got 2 other folders that I've created. So we've got a conf folder. I've actually been running a few things here, so I've got some thread dumps. But we have a server XML. In that server XML, this is our Tomcat configuration. As a general rule, the things we'll set here are connector port, and if we are running SSL, we will define a connector for SSL to connect. Our recommended setup, even if you're running a standalone dotCMS, is to run dotCMS on a high port. You should not be running dotCMS as root. So it should be, as a dotCMS user, we generally go to port 8080, which is sort of a standard web app server port. And then we'll run something like HA proxy or Nginx in front of it, running on port 80 that forwards to dotCMS. We also generally will terminate SSL at the Nginx proxy. Because there's no need to have SSL between Nginx and dotCMS when they're, particularly if they're on the same server, but even within the same subnet, we generally leave it open between them, and then just block direct access to the dotCMS nodes from anywhere but the proxy server. So you make whatever changes are necessary in here. You can certainly make any standard Tomcat configuration setting max threads, and you probably will want to adjust the threads in here at some point, depending on your level of traffic and what your hardware can support. Generally, we start at around 150 threads. Then the next configuration file that we always change is the context XML. So here we've come into our plugins. We've come into the config plugin under root, .server, Tomcat, web apps, root, meta-inf. And this is the key one that we have to change because this is how we get our database connector. By default, dotCMS is running an H2 database just for proof of concept and to test that everything's up and running properly and that dotCMS works. But it's not really a viable tool, even in a development environment. It's not really going to be a good way to operate. You should be running against an actual database. We include all of the connectors for whatever database you may happen to want. Our max total connections default is 60, which is certainly enough for a development or test environment and certainly not enough for a production environment. Again, I generally recommend starting at about 150 connectors. If you're running a cluster, you have to consider how many simultaneous connections your database can handle and then divide that across the cluster. We also recommend leaving enough threads free. So if your database can support 200 simultaneous connections, you want to leave maybe 10 free, not allocated for database overhead operations, because you can end up getting a resource contention if you use up all of the connectors. This is a file also where you can change your mail server configuration if you have a need to do that. In general, most environments I've seen simply use the default mail configuration, but if you do need to customize it, this is where you would do it. So that's how you use the configuration plugin. We'll go back and look at some of the less destructive files now. Oh, I went too far. So the ones that we use most often are in the conf folder. We have a couple of ones that are here by default. The two that are here by default are this dotCMS config cluster and the .marketing config. If you're not using a cluster, then you won't use the config cluster one. .marketing config Ext Properties, everybody makes changes to that. Oops. Okay. For example, you want to change where you are storing your assets. You'll set your asset real path. Dynamic content path. So this is the path to where the cache is going to exist and where the default logs are going to exist. It is recommended that both of these be set because it makes it easier to manage backups and migrations and upgrades if your assets and your dynamic content are outside of the dotCMS application path. By default, they exist underneath the Tomcat folder. So moving them out of there is key to managing upgrades much more smoothly. There are a number of other things you can set in here, which will, where's my, Reference on. So a couple of other things we will set in here. There is an option which is now set to default of force Captcha. You can turn this off if you want. I don't really recommend it. What this does is it requires Captcha to be used on all public-facing forms. If you're implementing some sort of Captcha replacement, then that's fine. But you want to make sure that it's fully tested before turning this off. You can do language config in here, but it's easier to do it through the admin interface now. That's sort of a leftover configuration. There is a tool that's built into dotCMS called clickstream tracking, which is it's basically gives you some simple analytics, and it's a true false. If you have a large amount of traffic, I strongly recommend using something like Google Analytics and turning this off, because clickstream generates hits to the database and writes to the database for every single page that gets loaded. And it can end up chewing up a lot of disk space and producing a great deal of CPU usage and I/O overhead. So it can actually be a big performance hit if you have heavy traffic. So we generally recommend, and I believe it's off by default now, but it is something that if you're not using it, we recommend turning it off. The TinyMCE tool, which if you go into, let's go in here. So this toolbar here is controlled by TinyMCE. If you have a custom configuration for TinyMCE, then you could put in your path to config. And then it will use whatever configuration you have set up in there. There are a couple of really useful things that I recommend setting up in a development environment. The first of which is show velocity files. What this does is it will save pre-rendered velocity for a page. So if you go to your index page here in the browser, you load it. You know, there's a bunch of different components that make up that page. If you're trying to troubleshoot something that's going on, it can be kind of a pain to try and dig through all of that. So what this does is it will render the entirety of this page as one file or it will save it pre-render. So you've got all of the raw velocity code indicating everything that's happening, and that gets saved in the assets folder, which allows developers to look and see the entirety of what's being loaded on that page in one place rather than having to jump between a bunch of different contentlets and figure out where the problem is. The second one is log velocity templates, which just increases the logging level of velocity. So the velocity logs provide a lot more detail, which is also really useful for troubleshooting. So those are that's the essentials of using the configuration plugin. There's a couple of other things you can set up in here. For example, and we'll talk about this in detail when we go into LDAP, there's the portal Ext Properties. If you're wanting to use something like SAML for your authentication, then there would be a plugin. We actually have a SAML plugin on our GitHub that you would put in this folder into your configuration there to deploy. You also have the option of using something like OAuth. We have pluggable authentication available. What I see most often these days is people are moving to using SAML because it's fairly robust and easy to manage. LDAP is a bit of a headache on both the client and server side. SAML is a much more scalable and manageable solution. So let's go into the cache again. And we're going to go in a little more detail this time. Caching is the primary performance layer for dotCMS. We try to make everything happen in memory if possible, rather than hitting your database, and try to avoid hitting disk, but sometimes that's necessary. So when you first start up, there's not a lot of data. It can take time to build up an idea of, okay, what are our traffic patterns like? What is our memory like? And figure out how best to tune your cache. Over time, it's not something you need to monitor constantly. Every few months, check in, make sure that things are looking good and healthy and you're not seeing any problems. When you want to look into the cache details, we have this refresh stats, which brings up a great deal of information about what's going on in the cache. Both the in-memory cache, which in this case we're using caffeine, and the H22 cache, which is our on-disk cache. That disk cache, just like we have our assets separate from the database, we also have a disk cache, which is for those kinds of things, which is for large objects, binaries, that you don't want to have sitting in memory, but you want to have quickly accessible. And the one other reason we might have something in an on-disk cache is it's something that gets accessed a lot, and you don't want to have to rebuild it every time you start dotCMS. So velocity cache is always a good candidate for being on disk. Velocity macros, good candidate for being on disk, because that way you can restart dotCMS and not lose all of those objects that are in there. Like 360 objects would have to be rebuilt every time you restart dotCMS if they weren't being saved to disk. Content-lit cache, also a very popular one to go on disk. 856 objects in there. So yeah, that's a lot of stuff to have to reload into memory if you didn't save it to disk. So when we look at the content usage, we look at a couple things to try and determine, is this region of cache being used efficiently? Are there things that we need to adjust here? And we start with, what is the region name? Are we using the default region? Using the default is just using all of the out of the box, no changes. We definitely do recommend over time that you explicitly declare the regions of cache that you're wanting to make any kinds of adjustments to, and not use the default. The standard configuration is to have 1,000 objects in a region. Out of the box, we've configured some to be different because it makes sense for them to have different settings based on what types of content go in there. But this is the number of objects that are initially configured to be in there. Now, the size indicates how many are actually in there at this point in time. And this will fluctuate throughout, any given week, different points of the day due to things like Java garbage collection. You'll see, or objects expiring in the cache. You will see higher or lower numbers and higher or lower free memory, which is why when you're trying to determine what changes to make to cache is to track this free memory and to track these stats several times a day over several days to determine, do we really always have this much free memory, or is it normally more, or is it normally less? And are these regions that look bad right now really problematic, or is it just I happen to see it at a bad time and it's normally fine? So those are a couple things you want to be aware of when looking to do cache tuning. The load is the number of times that a cache lookup is done to load a new value. The hits indicates the number of times that it actually was found in the cache, and versus having to go into the database. The hit rate is simply hits over load. And the load time average is how long does it normally take to load something from the cache. And the eviction is how often did we kick something out to make room for a newer object. So object A exists in cache, object B doesn't. There's only room for one item in the cache. Someone goes to load object B, object A gets kicked out. So that's when evictions happen, generally. When a particular region is full and another object from that region gets requested from the database, something has to get kicked out. So because this is demo, we don't have any regions that are really candidates for editing. So let me pull up an example. So this is from an actual client site. It's a slightly older view. We don't have the separation between the in-memory and the on-disk. They're all just kind of bundled in together. You can see here, I've got a Guava cache provider here and an H22 cache provider here. Actually, I've got content-lit cache with both in-memory and on-disk. Currently have 3.4 gigs of free memory out of 10. And as we look at a couple of objects, the first thing that I always look at is configured versus in-memory. So in a situation like this, if you're seeing, block directive doesn't seem to be performing very well, but adjusting this cache isn't going to fix anything because it's nowhere near the in-memory setting or the configured settings. So increasing your configured setting isn't going to help this area perform any better. You may need to look at the code behind what you're using in the block directive cache to make it more efficient at that point, because it's not a caching problem. We come down and we look at category parents cache. It is right at the limit, and the load, it gets objects out of cache a lot. The hit rate's pretty good, could be a little bit better. Quite a few evictions, but not horrible compared to the load. So this is certainly a candidate for being adjusted in this situation. We can come down and look at the content-lit cache, which again, configured and in memory, it is at the limit. Even if it's a little below the limit, say it were 100 or 200 objects below the limit, because of the size in objects can vary, you can actually get a performance increase even then if it's a little below the limit but not at the limit. And we look at this load, a lot of objects getting called from here. The hit rate's pretty bad. It's 86%. That's something we can definitely benefit from increasing this content-lit cache. It's currently at 10,000 based on several gigs of free memory and a lot of evictions. I would go ahead and change this to 15,000. And I can look down further. And again, we'll see something like file asset metadata cache is at its limit and a fairly low hit rate. So that's another candidate. May bump this up to like 1,500. In general, depending on how low the hit rate is, I like to start by increasing a cache region by between 25 and 50%. If this number here were something like 40% hit rate, I might bump it to 20,000 instead, double the size of it to try and improve performance there. But those are the basic guidelines on figuring out what you need to adjust in the cache regions. we give a little bit more and better laid out information now than we did when I grabbed that screenshot. So now we also actually include the number of hits, and we separate out the on-disk cache and the in-memory cache. The on-disk cache you don't set a size to. It's simply limited by the amount of disk space that you have. So setting the cache, you will configure your cache through this .marketing config. Conf.marketing. As you can see, I've already put in a cache configuration change in my local environment. Using the standard in-memory cache, it's very simple. You simply put in cache.regionname.size to what you want to set it to. There are more details you can go in particular, if you're wanting to use Hazelcast as your cache provider. In a cluster environment, we're going to go with the Guava, and a standalone, we use the Caffeine. The H22 cache provider is the on-disk provider. So if we're specifying any particular region, we're generally going to use the on-disk as going to be part of a chain, which is where you have multiple layers of cache. And we'll start, in the example I give here, and which is what is going on in this particular setup with content-lit cache being both in memory and on H22. We'll actually set up a chain. So we'll say, okay, content-lit cache. We want our first layer of cache to be the Caffeine cache, and then we also want to use the H22 cache. And there's no region-specific settings for H22. The only changes you make to H22 affect all of it. And there's not really any reason that you should need to change any of these. We've got it pretty well tuned. But if you do, this is where you would change it also. It all gets adjusted here in this .marketing config file. You also have the option of using a Redis cache provider. We've got our configuration guidelines in here in our documentation for that. And it's again, just really straightforward, all done in the same place through the root folder plugin. And you simply plug in your values for all of these variables once you have your Redis environment set up. So there are a couple other cache tools available also. First and foremost, and is actually referenced here, block directive, and that is a tag-based cache that you can actually use within a page or contentlet, where you use the velocity tag of .cache to wrap a piece of content and say, the rest of this page may change all the time, but this particular block, I want it to hang out in cache for 6 hours or 5 days or however long. You may have a section that's like your contact information on a page, and you say, this whole block, including our link to our Google map and all of that, it's 100K of content, and it doesn't change very often. We want this to stay in cache for a week. And then that way, instead of having to refresh that from the database more frequently, it only needs to be refreshed from the database to whatever this TTL is set. And that's a really good way to optimize pages that have a mix of very static and very dynamic content, and to improve the efficiency of the pages. The other tool that kind of works in conjunction with this is the page level cache. And it's particularly useful on index pages, whether for the main page of the site or for some sub page. You can actually cache the entire page for however long. By default, all pages are cached for 15 seconds. you say, well, your homepage gets a ton of traffic and it doesn't change that often. So we want to bump this up to like an hour. And that means for that entire hour, you've reduced the number of calls to the database every time someone hits that page. Instead of, say you get 10,000 hits on the homepage in an hour, if you suddenly only need to go to the database for the first one of those hits, you've greatly improved your site performance. The downside being that every object on this page is cached for that page. So if you have a contentlet that shows up on your index page and is also on your about page, well, you update it, the new content's going to show up on the about page, the old content will still show on that index page until that cache TTL expires when it reloads from the database. So that's the one caveat for using the page-based caching, is everything on that page remains in cache, even if underlying objects change until that TTL expires. We already mostly talked about indexes. One thing I didn't touch on is this health. So the health indicator, which is particularly useful in a clustered environment, gives you information about the index itself. Green indicates it's healthy. Yellow indicates a non-critical error. It may be degraded performance. It could be because, particularly in a cluster environment, it could be because there is a sync going on between the two nodes, or because it cannot connect to the other node. So a yellow is not necessarily problematic. If you see a yellow indicator, it's worth clicking on it and looking at the details to see if it's something that needs to be investigated further, or if it's just that the indexes are syncing or something like that. And it can indicate like a network problem. Or it could indicate you may have one node that's down for maintenance, and so you'll get a yellow health indicator until that node comes back up. Red is a critical error, which will mean search is not working at all, or it's not working properly. And so it's important to resolve that as quickly as possible. And you can pop this up and see the basic information about it, see what node this identifies as if you're working in a cluster, and so that's useful to have. So, for example, if you've got two servers that have 3 replicas in it, then the health will be yellow because Elasticsearch can't find the 3 servers because you've only got 2 going right now. If the data becomes corrupted, for example, then your index will become red. If Elasticsearch runs out of disk space, that will also cause a problem. And Elasticsearch is pretty paranoid. Once you hit 85% disk space used, it will start throwing errors in the log file, and it does cause some performance issues when it starts doing that, because it's not writing effectively, because it starts getting paranoid about running out of disk space. So monitoring your disk usage is definitely a key part of keeping your Elasticsearch happy and healthy. When you are creating an index, you have the option of selecting multiple shards. The way that dotCMS uses Elasticsearch, it makes more sense to have a single shard. So having more shards is good for write performance and allows distributing a big index across multiple disks. We're not using it that way. We want to optimize reading because we do a lot more serving up content to people than we do creating content and indexing it. So for the way that we use Elasticsearch, it makes more sense to use a single shard because you actually get performance problems for serving up pages if you're using multiple shards. So we always set it to use a single shard. As you fire off a reindex, then you'll get a dialog box that pops up, tells you what's going on. It gives you three options here. You can stop a reindex that's running, you can stop and make it active, and you can download any failed records. So if you see that reindex bar stops at 90% and just never completes, you can then stop and make it active and download all of the records that the reindex process was not able to process, and then investigate those. You can open a ticket with us, and we can help you figure out why were those not able to reindex, and we can work with you to get those resolved. Once the reindex has been complete, it goes active, the old one becomes inactive. If you're working in a cluster environment, that progress indicator can stay at 100% for as long as it takes to sync the new index across the nodes. If your index is 15 gigs, it's going to take some time to copy that all over to the other instances and to validate it and activate it. So it can stay, depending on your network throughput and performance, then that will determine how long it's going to stay at that hung at 100% notification. As I noted earlier, you can also use an external Elasticsearch, in which you wouldn't be doing any of these index management tools here in dotCMS. Your Elasticsearch team would be managing that. And in our documentation, we do have information on how to set up your Elasticsearch. There it is, external Elasticsearch. I've only seen one or two environments doing this, and they're using it very effectively, but it definitely requires an experienced Elasticsearch admin or team to get it up and running. Connecting dotCMS to it's pretty straightforward. Again, what's most often done is people will take this chunk, put it in their configuration file, deploy it, and start up dotCMS. All of the difficult part of this happens at the Elasticsearch server. So we've looked at the basics of a dotCMS environment here. I'm going to look also at a cluster environment. So cluster looks pretty similar, except that we've got multiple dotCMS nodes. And whereas here you could have your database and assets on the same server as dotCMS, in a cluster environment, it has to be separate. Your database and your assets are going to be on a separate machine, or separate VM, at least, in the same data center. Each of these dotCMS nodes will have equal access to those network resources. The cache and the index will remain local. The function of the cache in this context, aside from providing performance, the cache will manage invalidations. If you have a user who is connected to node 1 through the load balancer, they make an edit to a piece of content, hit save. The index knows, oh, this object has changed, here's the new version. The cache knows, hey, there's a new version of this object, I've got to kick out the old one. So the cache communicates to the other nodes in the cluster, invalidate object with this ID, and get the fresh one from the database next time someone asks for it. The index, you've saved, index is aware, okay, this object is new, I want to communicate what version of the object to use to the other nodes. It syncs to those other nodes, says, hey, this is the new version of this object. This version number for this object is what you should be looking at now. And that keeps everything in sync across the nodes. One thing to be aware of in setting up your load balancer is that we do not share session information in between these nodes. So you have to have session affinity turned on the load balancer so that if someone connects to node 1, for the entirety of their session, they're going to be on node 1. Next time they come in, they may go to node 7, and they'll stay with node 7 for that entire session. But for the duration of a given session, they will always be connected at the same node. We've had questions about having nodes in different data centers. That's not what clustering is for. That's geobalancing. You can use push publishing for that, which we'll talk about when we get to push publishing. It's what push publishing was designed for. Clustering all of the components of the cluster, every dotCMS node, load balancer, database, asset server should all be in the same data center. Should all be on the same subnet, really. Which again, particularly in a cluster environment, having all of these in the same subnet reduces issues with things like firewalls. Particularly when you're setting up caching, it can be difficult to use automatic clustering if you've got a firewall in the way. So let me jump over to local instance. So there are two approaches to setting up a cluster. The first of which is called auto-wire clustering, and it's the preferred method. In preparing for auto-wire clustering, you need to make sure that you have a database that all dotCMS nodes can access equally, your assets share, that they all have equal access to, and that there is a load balancer that is not on this diagram, but you have a load balancer that is serving up to all of the dotCMS nodes. To set up auto-wire clustering, we'll go in and we will apply a license. Now it's a single license. I wanted to pack. There we go. I do not want to use this license here that I just applied because it is a platform license, and I want to use a cluster. I can use cluster with platform, but my cluster licenses here are a different level than the platform, and you want to make sure that all your licenses are the same level. So I'm going to remove that license, and I'm going to go with, I have the option here to delete a license, which deletes it from the repository. I'm actually going to delete my my platform one because I don't need it. And now I have the option to apply a license. I say I want to apply this license. I now have a licensed dotCMS instance because clustering is not available to Community Edition. So let's go to 29. Unless its IP address has changed. That's changed. So there. Let's see, that may not be correct. We have started them both up at the same time. So this second node that I brought up, it's a little sluggish. But I can see in here, it's still only showing license. Configuration. Not sure why it's going so slowly. All right. That'll take a minute to update, but once the database updates, yeah, so I've got cluster 22.2 is one server and one is the other. And once the database gets synced, it'll show there are two nodes here, two nodes in my index. I've got both licenses applied. But it's that simple. It's if you're setting up a AutoWire cluster, you start up your first node, apply your license, start up your second node, it will automatically grab its license. Start up your third node, it'll grab its license, and you're just limited by the number of licenses you have. So setting up AutoWire clustering is obviously the preferred approach because it's much simpler. You can also do manual clustering, which is where you have to individually go into each node and edit the cluster config properties. So in this case, and to make those changes, one of the reasons that people try and avoid the manual configuration is managing manual configuration is very tedious. So what you have to do is anytime you're going to make a change to a cluster, you have to go in, change this file on each node in the cluster, and save it, shut down the node, deploy plugins, start up the node, go to the next node, make the changes, shut down the node, deploy plugins, start up the node, go to the next. So yeah, it's a very tedious process to manage. We have our documentation on managing or on what to configure, but I'll go over it real quick here. First thing we'll do is we'll turn off AutoWire clustering. Second thing we'll do is we will make sure that the distributed indexation is set. We will set our cache configuration. First thing we do is we set cache force to IPv4. The way that our cache layer works, it will try and grab an IPv6 interface if it's available. and we've seen some problems with that, so we force it to 4. We declare what protocol it's running. It should just always be set to TCP. We never use UDP for this. We've had some problems with packet issues. We'll want to look at the bind port. What is the port that your cache is running on? By default, it's going to be 7800. Doesn't have to be. We declare what is the IP address for the cache. In this case, it's going to be 192.168.1.27. And then we get into, we have to declare all of the hosts in the cluster. So in this case, it's going to be 192.168.1.27. And we're running on port 7800. And we're also going to have 192.168.1.26, port 7800. And you add all of the nodes in the cluster. So if you want to add a node to the cluster, you have to go and do this on each node and restart each node in sequence in order to get it up and running. We set up our index information. We turn off auto-expanding replicas. That's not useful in the way that we use Elasticsearch. We set it, the port that it's going to run on. When you're setting up manual clustering, we've had some odd conflicts if you run it on adjacent ports. So we recommend skipping ports in between nodes. We're at 192.168.1.27. We declare all of the hosts in the index cluster. And what port they're running on. So in this case, I'm going to be on 9301. I'm going to set my other node in my cluster. 9304, skip a couple. We'll set our default, our number of replicas is going to be the total number of nodes in the cluster minus 1. So if you have 4 nodes in the cluster, you'd set this to 3. In this case, we've got 2, so I'm setting it to 1. And we turn off the HTTP interface for Elasticsearch because in a cluster environment, it is enabled and it is not secured, so we recommend turning it off. So that's how you set up manual clustering. It's pretty simple to do. It's just time consuming, particularly when you have to do maintenance on nodes in the cluster. It's much easier to do auto-wire clustering. And again, the only reason I've seen people not use auto-wire clustering is because they have very restrictive firewall rules. And my view is that you've got nodes that are in the same subnet that there's no public access to them. There's only access to the load balancer. They should be allowed to communicate openly between the nodes. Obviously, there are environments where the security policies prevent that, and in those cases, you have to do manual clustering. So let's talk a little bit about the log files where you can check on all these things. By default, the log files are going to be located in the .secure folder. In my case, I have moved that .secure folder. And so I have my license, my velocity, and I've got my logs. The most important log file is going to be .cms.log. That's what you're going to be looking at when you have anything you're trying to troubleshoot. 99% of the time, that's the first place you're going to look. If .cms will not start up, you'll want to look at the Catalina out, which is under the Tomcat logs folder. So a couple of the log files that we have here, start at the top, the admin audit log just tracks basic functions that are going on in the admin or the interface. So I uploaded a zip file, uploaded a zip file, freed a license, deleted a license, chose a license. Those are all logged here in the admin audit. dotCMS log logs a lot of stuff. We've got pretty noisy logs. There's a lot of info and warn level stuff here. The biggest ones you're looking for are going to be error, severe, and fatal. But you may have logs that show as a warn or info level that are still problematic. So if you're having problems with a particular piece of content or something, you can look in here for any indicator of what's going on with it. Push publish log, there's nothing in there right now, but that's a log of all push publish transactions. I'll talk about that a little more when we get into push publishing tomorrow. .security is the login log, just indicates who is logged in from where. Site search logs all of the site search jobs that have run, and we'll talk about site search a little bit tomorrow. Test log isn't used. User activity is a track of, similar to the admin audit log, is a user activity log. And again, it will not provide details of what was done. The database is where you want to reference that. So if someone's made a change to a particular piece of content, we'll show in this user activity log, this user edited this content ID, but we're not going to have the details of what the edit was. That you'll have to get out of the database by looking at the history of that object. The velocity log logs what's going on in velocity templates. And as I noted earlier with that log velocity templates, that simply increases the level of logging in this .cms velocity file. You can adjust the logging levels. So you can go into the log4j configuration file, and you do that through that admin plugin or the static plugin. And that would allow you to go in and change what logging level you want for any particular region of logging. So yeah, you'd come down here into the actual level settings and say I want to, for logins, I want to have debug level logging because we're having some problems with someone's logins. So you can increase the login level on that particular region of the application and get more information about it.